Good day, sir. We are the group 2 and we are here to discuss about the moment of force. So for the members, Granado Jericho, me, myself, Galera Joshua, De Castro JB, Calzado Mark Raven, Lucela Dennis, Nel Federizo, and Mark Gino de la Peña. So for the next presenter, please unmute your mic. Next presenter, please. JB.
Next slide. Moment of a force. Topic of a force is a measure of its tendency to cause a body to rotate about a specific point or axis. This is different from the tendency for a body to move or translate in the direction of the force. In order for a moment to develop, the force must act upon the body so that it does not pass through the centroid of the body. A moment is due to a force not having an equal and opposite force directly along its line of action. Next presenter is Gisela.
Moment of force. The magnitude of the moment of a force acting about a point or axis is directly proportional to the distance of the force from the point or axis. It is defined as the product of the force F and the moment arm D. The moment arm or lever arm is the perpendicular distance between the line of action of the force and the center of moments. Next presenter.
The center of moments may be the actual point about which the force causes rotation. It may also be a reference point or axis about which the force may be considered as causing rotation. It does not matter as long as a specific point is always taken as the reference point. The latter case is much more common situation in structural design problems. Next presenter, please.
For the sample problem, you have T1, T2, T3, and theta is equals to question mark. Since a string under tension pulls inward along its length with the force given by the string tension, the forces acting at this point are shown in this figure. So for figure 3.2, the figure A is the forces at the left junction of the strings, and the figure B is the forces acting at the right junction of the strings. Now, for the next presenter, we have Leonardo.
Next, thus the sum of the x components of the forces is 0. Therefore, negative T1 sine 35 degrees plus T2 is equal to 0. This is our figure 3.4. And the sum of the y components of the forces is 0 as well. Therefore, T1 cosine 35 degrees minus 40n is equal to 0. This is our 3.5 figure 3.5. Now we look at the right junction of the strings. The forces acting here are shown in figure 3.2b. So again, the sum of the x components of the forces is 0. Therefore, negative T2 plus T3 sine theta is equal to 0. This is the figure 3.6. And the sum of the y components of the forces is 0 as well. Therefore, T3 cosine theta minus 50n is equal to 0. And this is our figure 3.7. Next slide. And at this point, we are done with the physics because we have 4 equations for 4 unknowns. We will do algebra to solve for them. So from equation 3.5, we get T1 is equal to 40n over cosine 35 degrees. The result is 48.8n. And then equation 3.4 gives us T2. Excuse me. So T2 is equal to T1 sine 35 degrees is equal to, we're gonna substitute. So 48.8n, the T1, sine 35 degrees is equal to the result, 28.0 newtons. We now rewrite equation 3.6 as T3 sine theta is equal to T2 is equal to 28.0 N. And equation 3.7 as T3 cosine theta is equal to 50 N. Next presenter, please.
Now, if we divide the left and right sides of 3.8 by the left and right sides of 3.9, we get tangent theta is equal to 28 newtons all over 50 newtons is equal to 0.560. And then theta equals tangent over -1 times 0.560 is equal to 29.3 degrees. Finally, we get the T3 from equation 3.9, which is T3 equals 50 newtons all over cosine 29.3 degrees is equal to 57.3 newtons. Summarizing, we have found T1, which is 48.8 newtons, T2, 28 newtons, T3, 57.3 newtons, and theta, which is 29.3 degrees. And that is all for our presentation. And this is our reference for this presentation as well. Thank you.